Well, hello, and thank you very much for joining our IDA webinar. My name is Rob Thornton. I'm the president and CEO of IDA. I'll be the moderator for today's session. Before I introduce our presenter, I'd like to just share a couple of housekeeping notes to apprise everybody. Patrick, could you go to the next slide, please? So the webinar will be a presentation by our friend and colleague, Patrick Lach. And we'll have question and answer at the conclusion of the presentation. I would ask, though, if you have questions as Patrick goes through the content, please post them in the Q&A box, and we'll aggregate those, and then we'll have time at the end for answers to your questions. So I'd ask that you submit your questions. Everyone who's on the call is in fact muted, but that's the format for today. The webinar will be recorded, and within usually a day or so, once it's been compressed, we'll send out a link so that you can review or share the streaming presentation at that time. You'll note, if you look in the chat box at the bottom right, you'll see that well, there's a question where we will post a link to the slides. There it is now. So there's a link to the slides if you'd like to follow along. I know some people like to print them out and kind of make margin notes. So that's the slide deck for today's webinar. In addition, that'll be provided in its entirety after the webinar is completed. So again, we'd like you to submit your questions in the Q&A box, not the chat box, and then at the conclusion, we'll review those questions. If you're having any difficulty with either audio or video, please send a note to Jason Beal in the chat box, and we'll do our best to solve for that. If you're really having difficulty and you're not, well, I guess in order to have a difficulty, you need to be hearing this. But the number to call is 508. 366-9339. That's the IDA office outside of Boston Eastern Time. So Patrick, next slide, please. So it's my pleasure to introduce our presenter for today, Patrick Lach. Patrick is Vice President, Sales and Business Development for Maxi-Therm, headquartered in Montreal, Quebec. Patrick really started in the steam industry at the age of 14 and is now very well versed in both the challenges and opportunities of steam production and distribution generation systems. He's over that time really developed a keen appreciation, and I think most would say a passion for steam in the course of his career. He has a deep understanding of the challenges of using steam efficiently and safely, and in his role at Maxi-Therm, he interacts significantly with a whole range of industry participants, including consulting engineering firms, manufacturers representative firms, energy services, ESCO organizations, mechanical contractors, as Maxi-Therm really does, I think, support a full range of opportunities in the industry. I'm really pleased to have Patrick presenting for us today and sharing his insight, and frankly, I think some very valuable information on both the advantages and how to use steam more effectively and efficiently. So Patrick, at that, I'm gonna hand it over to you. Please take it away.
Thank you, Rob. Just to clarify, when I started at 14 years old, I was doing drawings for my father, so we're a family-owned business. We do have American partners, but the majority share is between me, my cousin, Gabriel is our professional engineer inside the office, and my brother taking care of fabrication and quality control. So basically, I have a fun job, traveling all over North America, meeting people, and actually, you see my background of Maxi-Therm, but I'm not in Montreal. I'm in beautiful California, meeting customers this week. The other thing I want to be sure of before we go through this webinar, I really hope everybody watched the video that was presented to you to watch before this webinar to give you a good intro of our vertical flooding design. Otherwise, some of you might have a hard time to understand some concept of this presentation. So this presentation is many years ago when we started with my father. Everybody was saying to us, oh, you're in the wrong business. Steam is going away. It's a dying dinosaur. And since then, we never stopped growing. And today we have, lately we had a wonderful conference with you, Rob, in New York City. Things are looking great for steam like never before. So the presentation today is more regarding why use steam, basically, and what we need to consider about steam. And I think it's a great steam energy. It's a great way for heating and maybe more. So let's start. The agenda, so we're going to go basically steam basics. It's mainly in the video. It's on YouTube. You wrote Maxi-Therm on YouTube. You'll find a 17 minutes video where I'm going through another PowerPoint about other benefits in our steam solutions. So I'm going to go very quickly about steam basics and vertical flooding design. We're going to discuss 100% steam condensate closed loop, 95% efficiency generation for steam generation, hydronic hot water versus steam primary loop. So that's the main purpose of this presentation today, and top 5 reasons to consider steam. The presentation you're seeing today, it's more presented in our steam training in Montreal. We do 2 to 4 times a year. This year is 3 times. I'll tell you more about this if you want to know more about steam and Q&A at the end, obviously. So this is the steam table on ASHRAE book. I just want to pay attention again, recall on that video that you watched. So as higher steam pressure we're going, temperature of the steam is going higher. Latent heat, the change of phase of 1 pound of steam that turns 1 pound of condensate, it's going down, right? And then the volume of the steam goes drastically down. So that explains you why most of boiler room works at high pressure steam is a question of transport. And then we knock down the pressure because latent heat is higher and temperature is lower and it's easier to control. Sensible heat, though, it's going higher. Sensible heat is directly related to the definition of 1 BTU. A pound of water that took 1 Fahrenheit took 1 BTU, freezing point 32, steam point 212, difference 180. Obviously, this number is going higher. What you need to remember, sensible plus latent total heat, that number is going higher. So we have more heat available at 100 PSI than 50. So this is a typical conventional design for warm heat exchanger, right? So you're coming out of the steam boiler somewhere, pulling out high pressure steam, coming in every mechanical room or building on the campus or in the city. You need a PRV station. Some of you will go with a 1/3, 2/3, and also 2-stage, let's say 150 to 60 and 60 to 10 for better reliability or control. You need steam safety relief valves, vent to the roof, bigger pipe, low pressure steam volume is much bigger, so more welding, more firewatch, more installation. Big steam noisy control valve, 1/3, 2/3, state-of-the-art, a dedicated condensate pump, steam or electric motor pump. Then we go back in the main receiver tank and you need all those pieces of equipment around the units, which, you know, a lot of leaks over the next 20 years and maintenance over the next 20 years. And this is a 2-stage PRV station, takes a lot of room, a lot of footprint. There's a cost for those ugly walls, a cost for fire protection, lightning, and everything else. All this, all gone. And this is what we do basically, is we're coming directly with high pressure steam, again, related to the other video on YouTube, and we control the condensate, full steam pressure, no pressure reducing valve, no more steam safety relief valve, no more condensate pump, etc. So let's make up water by doing so, 0 flash loss. Because condensate, I'll show you, come out at 200 Fahrenheit and lower at full load, okay? 0 flash loss, no more pressure reducing valve, no more steam safety relief valve, no pumping station, substation, smaller steam inlet on the condensate piping, smaller control valve, up to 10 million BTU process. It's a 1/2-inch control valve. And that's the only moving part you need to keep in stock, right? All the other parts around remain in the same position during all operation. No vacuum breaker, so this is huge. No more air injection from the flash tank, from the vacuum breaker, okay? Up to 20% energy saving, I'll show you in a few slides. Stability set point 2 Fahrenheit. A lower maintenance cost, 50 to 1 turn down. That's very important to remember. Less blowdown on the border. So if you go 100% steam condensate closed loop, surface blowdown will be under 1%. Chemical costs drastically down. Okay, maintenance level drastically down. So this is our #1 competition, a condensing natural gas boiler, right? And this is the flue gas exhaust. We all know that the dew point of the flue gas is 140 Fahrenheit. So in order to condense that flue gas, you need a cold temperature return under 140. So that's why we want a low temperature set point. In today's world, low temperature set point make more sense because we want heat recovery from the chillers. We want to introduce geothermal, solar, and all kind of benefit of using those renewable energy. So let's apply this to Maxi-Therm. Let's control 120 Fahrenheit outlet temperature on the hot water side with a potential return at 90 Fahrenheit at full load. We can oversize the heat exchanger, that full load, instead of coming out at 200 Fahrenheit, we will come out at 130 Fahrenheit. If you had a condensing stack economizer on the chimney, well, that's what I'm going to show you in a few slides, how we can reach this, okay? Now, in my previous video, I showed those numbers. We compare a conventional design with a 1/3, 2/3 steam control valve operating at 6 psi because you always have a pressure drop to your steam control valve at full load. Comparing with 100 psi steam and condensate leaving at 200 Fahrenheit, the benefit was 6.26% less steam to do the same job. What would be the number if condensate is leaving at 130 Fahrenheit? 12%. Twice the savings. So you need 12% less steam at the point of use, and you got 10% plus more efficiency on steam generation. That's the benefit of 100% steam condensate closed loop. Less blowdown, less maintenance, less chemical. On the district energy perspective, where customer is buying steam, right? The number is greater, especially when they dump the condensate to drain, or there's no credit for the temperature coming back. But think also, if you have the condensing stack economizer, you can return cold condensate on domestic hot water. Return here is 40 Fahrenheit. We can oversize the heat exchanger, condensate leaving at 70 Fahrenheit. No quencher, right? So what will be the number if condensate is leaving at 70 Fahrenheit, still for 4 million BTU load? 16.5. What will be the number if the steam pressure is 150? Well, we're close to 20% saving at the point of use. A very small footprint. And you can tell any of your customer using this technology that the building on a district energy loop, whether it's a campus or a city, the building will have no chimney, zero on-site combustion, no gas vent, no steam vents to the roof. Very, very small footprint. And I don't need a natural gas certified technician to work on our system. A plumber can work on it, a pipe fitter can work on it, a control guy can work on it, a janitor can work on it, my mother can work on it, anybody. Now, this is a screenshot we took to Liberty Place building downtown Philadelphia, okay? They're dumping condensate to drain. We're using 129 PSI steam. You have, by the way, on the touch screen, you see the BTU monitoring and the flow rate at the actual flow rate. So we're having a 5.5 million BTU load right here. Look at the temperature return, 107 Fahrenheit. Look at the temperature discharge of the condensate. 3 Fahrenheit difference with the temperature return, because we're not at full load here. Full load will be, like I said, 130, depending on your set point and your temperature return, basically. There's other reasons, but yeah. So again, no quencher if you're dumping to drain. And there's benefits, and I'll discuss that later on, to return cold condensate as possible, even if you don't have a condensing stack economizer or you're not dumping to drain. And I was going to say, yeah, let's cover this in a few slides. Okay, let's jump on the 100% steam condensate closed loop. So we have a new patent pending. Sorry, this picture here. So this is coming from my friend Tony in Chicago. Thank you, Tony, if you're on the call. So the one you have on your presentation is this one. It's just a little change with multiple units. So the concept is multiple units of Maxi-Therm or flooding design in your building, campus, city, whatever, factory, and you're returning 100% condensate closed loop. So all we did basically is all those technology you see, hair preheater on the burner, condensing stack economizer, heat recovery on the vent condenser or the blowdown or whatever, all this, it's proven technology, right? It's all proven technology. So all we patent is all the ingredients together, okay? The cake, basically, like Tony always say. So the goal is to return cold condensate as possible. And then we want to bring it colder as possible going through a hair preheater. So let's say we're coming 110 Fahrenheit here. Coming at 110 Fahrenheit here, we can preheat the hair inlet of the burner. Then maybe we can preheat, let's say we're coming back here at 90 Fahrenheit. So maybe we can preheat domestic hot water loop if it's nearby, or a snow melt loop if it's nearby, or another building heat loop if it's nearby. So we want to get colder condensate as possible before getting into condensing stack economizer stage right here to get as much benefit as possible. So that's the basic concept of the 100% steam condensate closed loop. All right, so like I said, we're coming back here, let's say 110, 120-ish, coming back as cold as possible here to the condensing stack economizer stage, and then going back in the main receiver tank. And from the DA, we're going here as a normal stack economizer here. And you got all those heat recovery if needed. Because if it's 100% closed loop, you don't need a deaerator anymore. You will need a deaerator if you have a big load of steam injections, such as humidification, sterilization, and others. But depending, talk with your water treatment guys, depending on the load, max load, you might not need a deaerator anymore. And like I said, 100% closed loop. If it's 100% closed loop and you put clean steam, steam to steam heat exchanger for humidification and sterilization, then there's no makeup water. Absolutely not, right? So these pieces of equipment, like I said, might not be needed. So if you put all those numbers together, and you have this on your slide deck, that's the number you can reach. Let's say 90%, 92. It's a huge number. Plus chemical costs down, blow down, a lot of other benefits. And like I said, it's all proven technology. It's all on the website of the US Department of Energy, and we put all that together basically. The closed loop concept keeps the best advantages and avoid all major disadvantages. Generate water and steam at 95% efficiency. Dual fuel with lower maintenance, right? Higher reliability with long lifespan. Consolidate both space and combustion into one system. Proven and familiar equipment, no doubt about it. Virtually zero air infiltration means lower corrosion levels. We'll discuss that. And actually, I discussed this in the other YouTube video. Much lower water treatment and chemical costs, big time. Reduced need for a deaerator, consider a heated feedback tank instead. Low down below 1%. Okay, so that's the point I was looking in my head when I said, okay, let's move on. When you bring back low condensate, you can consider using non-metallic condensate piping instead of Schedule 80 pipe. And that's exactly what is happening in certain areas now. They're considering using this because we can bring at all time, in all conditions, low temperature condensate back to the boiler room. So non-metallic will live forever. What time is it? Am I going too fast? A bit fast. Maybe I can take some questions. Rob, what do you think?
I think you're going okay. Let's just continue with the presentation, because I'm concerned if we start taking questions, then we can really sort of veer off. Yeah.
Okay.
Take your time. It's really very great information so far. Thanks, Patrick.
All right. So let's move on to compare like a primary loop, high temperature hot water versus steam, right? So this, those next slides, it was based on, I don't know how many years ago, maybe close to 10 years ago now. Time goes by so fast. And it was a federal president design in New York State. And they decided to go high temperature hot water on the primary loop. In every mechanical room, they put the secondary loop together with a heat exchanger like this. So they could have considered to go steam here on the primary loop, but they decided to go hot water. Let's do some comparison. So the schedule specified a high temperature hot water loop at 240 Fahrenheit, 250 psi. That's big, 250 psi hot water. So as a reminder, 1 pound of water that raised 1 Fahrenheit needs 1 BTU. The same pound, 1 pound of steam that turns in 1 pound of condensate gives you about 1,000 BTU, right? And that's conventional design. Okay, so the hydronic loop for 35 million BTU total load that was specified. Okay, these are again reminders. There's 8.33 pounds per gallon of water, 60 minutes per hour, right? So the rise was 75 Fahrenheit on the primary loop. Okay, they will need 468,000 pounds per hour of mass energy and 937 GPM. If they will have considered steam, even 100% closed loop design, let's say, they will need only 34,000 pounds per hour of mass energy and only 69 GPM. The piping, steam piping will be a little bit smaller, and condensate piping will be much smaller. Temperature. When you return high temperature condensate, you have more heat loss than low temperature. So this table here shows, based on 20,000 pounds per hour of condensate back, temperature of the condensate, average temperature condensate here, right? Outside temperature, like room temperature, basically, here are the savings that you can make by having lower temperature condensate returning. It's not big, but I know it's part of the reasons why people consider hot water versus steam, because steam loss, there isn't. A 1 pound of steam travels like up to between 6,000 and 10,000 feet per minute. 1 pound of water with 1 BTU or Fahrenheit travels 600 feet per minute. So the friction is more high on hot water than steam. Steam is so fast, right? Okay, so for the hot water design, they had an N+1 boiler room here, 3 boilers, 1 is a backup. Each boiler need a pump to get in the loop, and you need big pumps to feed the building, right? So this specified a 60 horsepower main pump for the main loop, and each boiler need a 15 horsepower pump, right? So for a total of 90 horsepower in operation. If you put a feed water tank like this right on the floor, no head pressure, right? It's not like 30 feet high, you will need 15 horsepower pump. Kind of easier fix, in my opinion. And the pumps represent 3% of the overall energy needed for the hydronic loop. So a high temperature hot water boiler, if I'm right, if I'm not wrong, it's about maximum 85% efficiency. And then you remove the 3%, you're back at 82% efficiency. Steam boiler, what I presented you earlier, we're close to 90% efficiency. Okay, I'm almost done. It's going to be a short webinar, so hopefully I'll have a lot of questions. So let's go through the top 5 reasons to consider steam. Number 1 reason, no vents, no chimney. Really? Well, like I said, district energy, you bring steam in any building, you use a vertical flooding design, no zero on-site combustion, so insurance costs lower. No chimney, no gas vent, no steam vents. Those reminder of those numbers of earlier. No quencher, so no fresh water needed to quench the water when you're dumping condensate to drain. Partial list of cities around the country that have steam energy downtown. So if there's consultant engineers on the call and you're working on a new building, hospital, downtown, one of those cities, maybe steam should be considered, in my opinion. And I'll tell you the other reason why. This is where we have installed, so just want to show you it's a proven technology, no doubt about it. Number 2 reason, no acid contamination. So I'm going back to our number 1 competition, condensing hydronic water, natural gas. So I don't know if you're familiar with that type of situation that you're looking right now. This comes from the condensation, right? So every condensing natural gas boiler needs that little device here to neutralize the flue gas condensation because it's really acid, right? So did you know that number? Nearly 1 gallon per hour for 120,000 BTU input. You will dump a gallon per hour. So if it's a 5 million BTU, it's a big gallons per hour. Right? How many of those units there is downtown your city? Dumping acid to drain, because don't get me wrong, the first year, everybody remember what it is. In 5 years, nobody remember what it is. That little feature here. Dumping condensate to drain is way less damaging than dumping acid. And I'm sure the water treatment guy, if they find out, they will not be too happy about that. Number 3 reason, advantageous life cycle costs. Okay, so I started the business in 1998 with my parents, and at some point I left. I went to a local contractor and I sold boilers, burners, heat exchangers, economizer, water treatment, name it. I was involved in all 9 yards of steam generation. And also I was involved in condensing boiler, and it was high maintenance. I mean, we had service tech and we were doing quite work on those condensing boiler, and you need a certified natural gas technician and everything. So I'm telling you that this unit here, robust as it is, made in the US, TMA standard, not ASME, which is a higher standard, will last for a much longer time than any condensing boiler in the market. Way less, the longer lifespan. Number 4 reason, well, with steam, there's one thing we can do, and hopefully it's my dream, is generating electric power. So right now, steam turbine on the market for loads like we have, it's kind of high maintenance, things like that. So this is how it kind of looks like on the field. So hopefully we'll come with a decent size steam turbine, low maintenance at some point, but that's something that we can consider depending on your project. Again, if you do a boiler room and the average load is 20,000 pounds per hour and more, maybe you should consider to go, I don't know, a steam boiler at 500 PSI, go through a steam turbine, coming out at, I don't know, 60 or 100 PSI, feeding the building with it, and go with a flooding design and 100% steam condensate closed loop. So there's all kind of things to consider. And number 5, and last reason, it's my favorite one. I've been telling this for almost 20 years now. So when I started the business again, I did a lot of pulp and paper mills with my father, and petrochemicals and all kind of situation I've been through. And how many times I went in a mechanical room I see a steam leak. I go back 5 years later and it's still there, right? It's never an emergency when there's a steam leak. Like I said, pulp and paper mills, some of them look like a sauna. You know, you need to follow like a line on the floor and a corridor, open corridor in the factory. But at some point, at some places, the steam leak was so high, so to kind of protect people to walk through that alley, they put like a shower curtain. That's all they did to fix the steam leak. So there's nothing to worry about a steam leak. This is a steam club downtown Vancouver with Simon, our main draftman at the office. He doesn't look scared about that. And this is how some cities look like. When there's a steam leak, they put cones on it, on the manhole. If it was a natural gas leak, traffic jam right there. So if you're a hospital or a big building and you're having natural gas line all over the building for condensing boiler, air handling units, name it, when it gets old, like Seattle, 130 years old, it's a 130 years old steam loop. Of course, it's leaking everywhere, and I can imagine. But if it's natural gas in the building, you shut down the building. And you don't know where the leak is. You smell it, but you don't know where it is. Steam, you know exactly where it is, right? So your building will never run out of heat for a steam leak. If you have a hot water leak, again, it's an emergency care right now, especially at 250 PSI, like we saw earlier. It's right now. Steam, can you put a cone, wait for the next capital investment, next project? There's nothing to worry about a steam leak. Factory, still continue, building, still heating. It's me, Baltimore. Love it. And I found that picture on Google. It seems we can have a great steak on steam today. How about that? So, like I said, we have a steam training going on in April, October, November. You can register on the link you see on the page on the slide right now. You can qualify with your local rep. So if you go on our website, maxi-therm.net, there's a contact us page. You'll find your local representative, customers. I used to do a lot of trade shows, and these are the only 3 shows I do in a year. So 2 of the IDEA, Campus Energy and IDEA, will be present. This year at Campus Energy, we do have a poster presentation as well. And we do the PDC Summit this year, which is mainly for hospitals. So where I'm going at is instead of investing a lot of trade shows and everything, we decide to invest in our customers. So consultant engineers and end users, we pay for all your expense. So you need to qualify with your local rep. These are the dates. So we take care of plane, hotel, meals. You arrive on a Wednesday. We're having dinner Wednesday night, full day steam training on Thursday in our lab, half day steam training on Friday, and then you can go back home. So I invite you to fill the form right there, and we'll answer you shortly to see if you're in, if there's still a place available. And this is my next trips coming in also. If you're happen to be there and you'd like to meet with me and our local rep, and we have time on my schedule, I'll be more than pleased. You can see my email address. Just send me an email and we can discuss this, obviously. And the last slide is for you, Rob.
Well, thank you very much, Patrick, and we'll get to the questions. Actually, I think we're going to come back to this at the very conclusion. So, Patrick, thanks so much. I think you've laid out a really sort of strong argument for using steam, the advantages in size, water, energy savings, efficiency, etc. So, you know, it stands to reason that in a dense urban underground, I think you cited Baltimore, you know, Manhattan, of course. So they're given the constraints of trying to run, you know, sort of pipes in an urban setting like that. Is that an advantage for steam in particular to basically move more BTUs per diameter of pipe? Is that safe to say?
safe to say. I'm not sure I understand your question or point, but yeah, I feel even if there's a steam leak on the pipe or the steam trap or whatever, of course, you will need more energy source at the other end. But, you know, on, let's say on the overall cost of operation of a hospital, for example, I don't know for a big building operation, but I know hospital energy costs total, it's less than 3% of the overall cost of operation, right? So yes, it costs you a little bit more, but you have more reliability, I believe, with steam energy.
So we have a number of questions, and I'd urge people that are on the call to submit your questions in the Q&A box. So let's start there with, so first question from really from Maxi-Therm. Do you have a line of steam to hot water converter stations sized for large commercial and industrial applications? And the questioner, I think he's looking at a 115 million BTU per hour system. Do you have that scale of capacity, or do you do that with sort of ganging down?
So that's a good question. It all depends on the flow, also steam pressure, etc. Right now, the biggest system we've quoted so far, our project is supposed to go ahead next year. It's 60 million BTU unit. So that's the biggest one unit. But of course, we can operate in series or in parallel to do up to 150 million BTU.
Okay, very good. Next question: what is controlling the control valve on the condensate line? Is it temperature of the condensate level, the volume?
No, mainly temperature.
Okay, so it's really a temperature sensor, in which I would think, I think you made a point earlier that a lot of this equipment is sort of standard off the rack application of these kind of components, correct? So they're not necessarily unique or hard to find or hard to replace.
Exactly. We use pretty much all our purchase order are placed in Canada, but mainly in the US. So for instance, we do have at the inlet high performance butterfly valve, tight shutoff class 6. Again, I refer to my video on YouTube. Please, you'll see I talk about this. And we use Brave valve, which is based in Houston. So, so everything, the only outside, the main component outside of Canada and the US, but again, the order is placed in the US, but it's manufactured in Germany, is the control valve on the condensate. So since it's the only moving part, we wanted to put something very reliable, and easy fix, easy troubleshoot also. So we decided to go with that manufacturer for that moving part. Yeah.
Very good. Next question is, how does the Maxi-Therm system deal with fluctuations in the demand side? So the user, as their sort of load moves up and down, how does your system then respond?
So if it's on a closed loop system, like a building heat loop, hot water loop, we have like a 50-to-1 turn down. So we react quite fast. And also with our panel touchscreen, again, I refer to my YouTube video, but you can adjust the PID based on multiple data, so to have dead set point on change of flow or temperature inlet. On domestic hot water, it will be considered as any other steam hot water heater that control on steam. It will be considered as a semi-synchronous water heater. So you will need whether a master mixing valve at the outlet on the water side to have like dead on temperature control, or a buffer tank, or a good recirc, like 20% recirc at all time in the unit, just like any other semi-synchronous water heater. It's not because it's flooding, it's just because it's called a feedback system, whether you're controlling on steam or condensate. So domestic hot water is a little bit more tricky about temperature control. Yes.
I see. All right. And then question: how do you determine what the optimal steam pressure for a building is? Obviously our district steam systems have, they vary from city to city. I'd say the nominal is 125 PSIG. In some cities there's higher pressure steam, some lower. But when you're looking at the kind of the application to an end user, a building, how would you sort of identify the optimal steam pressure? Is that really just set by the size and scale of the system?
We work with the existing steam pressure, and by the way, we do quite a few projects with superheated steam and we don't need the de-superheater. Actually, we're more efficient when it's superheat because there's more sensible heat, right? So yes, and it's a funny question because that's a big debate inside our team at Maxi-Therm because there's some project. Let's say you're coming in, I'm just throwing a steam pressure like this, okay? It's like, let's say you're coming at 400 PSI, which is big. We won't go at 400 PSI directly in the heat exchanger. We'll put a pressure reducing valve, but I mean, we will use a control valve typically to do this, to reduce the pressure, something decent, like 100 PSI. Right. But if you're coming at 200 PSI, superheated steam like we just done recently, we will probably take it directly. So it's case by case, and we'll support the whole skid. Yes. Very good. Thank you.
Next question. Pardon me. With the closed loop system, you're eliminating condensate traps, right? So and how are you maintaining a 5 PSIG in the de-aerator tank? How do you?
Oh, that's a good question. So again, I refer to my video, but so it's like a steam trap on drip legs, right? So try to picture in your mind a steam trap on a main steam line. You have a drip leg, you know, at X 100 feet, a steam trap, you know, to remove condensate in the pipe. So let's say that your main steam pipe is 100 psi. You put a drip leg, a steam trap, and then you go, let's say, by gravity to a flash tank, for example. Okay, so everything before the steam trap, I don't know if you're watching me on the screen. So my fist is a steam trap. So everything before that steam trap, it'll be 100 psi. Even there, if there's condensate accumulating a little bit because you're using, I don't know, a bimetallic, that's what we recommend on high pressure steam. No, doesn't matter what brand, and or a thermostatic trap on a drip leg. So you'll have a little bit of condensate maybe backing up, not too much because it's just water drops coming out of drip legs. But anyways, my point is you'll be 100 psi on this side, no matter what. And as soon as you will purge, you will be at 0 psi. Right? And 0 psi mean 212. So you're not flashing off because you're going 100 psi to 0 psi. You're flashing off because you're going to 338 degrees Fahrenheit to suddenly 212. That condensate, that water. So you're flashing off to the flash tank. So you're at 0 psi. But if you're, instead of going directly by gravity to a flash tank, you're lifting 10 feet high. Every 27 inch give you 1 psi back pressure. So let's say you have 5 psi back pressure. You're pushing at 100 psi. You will move up and you will go back by gravity to a flash tank with no problem. As long as the steam pressure is higher than your condensate back pressure on a drip leg, you're always good to go wherever you want. Well, our system applies the same. As soon as you get off of the control valve, you are automatically at whatever is your back pressure, but we have no flash because we are already under 200 Fahrenheit. Again, I refer to my video on
And Jason, when you're Jason Beal on the call from our IDA, if you would be so kind as to share the link in the chat to Patrick's YouTube video, just so people have it as a refresher, that'd be helpful. Not that I want to distract them and have them go there at the moment, but so it's right at hand. So I think the last question also leads to this: what safeties are in place with if the condensate control valve should fail, and so how do you protect the PEX or the piping tubing downstream if in fact you've gone to a non-metallic piping system? Is there an exposure now if live steam at pressure You know,
like I showed you one of the slides, we do monitor the condensate temperature. So if something goes wrong, everything will shut down. So if something goes too higher than, I think it's 200 Fahrenheit, the alarm set point at 212, I mean, there's a kind of a gap there. We will shut off the system, send an alarm to the building automation. An alarm will be shown on the screen, and if we have redundancy on site, it will automatically switch over for a second unit to put on. And we also have all kinds of sensors. We have a flow sensors, we have a steam pressure sensor. No joke, 1 year. I don't know what exactly, I cannot name the customer, of course, but everything was approved and everything to operate, I'd say, at 125 PSI with a maximum steam pressure of 150. So everything was rated for 150 PSI, okay? But we do provide a pressure sensors. And then we received a service call because apparently the gasket on top of our heat exchanger broke and was pissing everywhere of steam, right? So we go in our data of our control panel to find out that, I don't know why, but the pressure went over 200 PSI. So now and those days we were just monitoring to do the startup sequence. Again, it's all explained in my YouTube video, the startup sequence. Now we have an alarm. If the maximum steam pressure is 150 and we're rising a little bit more, we shut down everything. So there's all kind of features like that to make it bulletproof safety-wise over time. I mean, we've been through so many bizarre situations over years that the system is, by the way, it's getting more and more bulletproof for any situation, and we're still working on it. There's some weird situation out there that happens, and yeah, so it's just getting more and more bulletproof. But it works like a charm. I just want to reassure people, this system, you won't hear nothing. I mean, it's so silent, you will barely know it's on an operation if you're not looking at the panel. There's no chick, bang, bang, whatever, water hammer. There's no sizzling from the control valve on the steam side, nothing. It's amazing how this system operates very, very smoothly.
Interesting, almost like an electric vehicle or Tesla, right?
Yeah, it's almost too good to be true.
Yeah. We'll save that. We'll save that conversation for another time.
You need to go see one.
Yeah, well, Stanley Steamer was really like one of the first vehicles, right? So maybe things will kind of come full circle. Another question, and this I think ties to your recent point that so in a retrofit application, let's say a district energy, a district steam system, can you really fully eliminate the high pressure drip piping system? And how would you interface with an existing like pumped condensate system, right? So a lot of the downtown steam systems are pumping condensate back or recovering it. Maybe the end user's using it for snow melt or some other sort of on-site application. How would a Maxi-Therm system kind of fit in that setting?
Of course, it's a case by case, especially on retrofit projects. On some projects, we keep the existing condensate tank, and we go directly there because there's so many units around using it. The advantage is we'll cool off a little bit all the other condensate because it's mixing with hotter and flashy condensate, so we kind of save a little bit of money there for the customer. And also by reducing the total temperature of the condensate, especially on the electric pumps, which cavitate over 190 Fahrenheit, so that helps also. Yeah, it's pretty much case by case, I will say.
Sure, that makes
20% of our projects, by the way, it's low pressure steam.
Right.
So sometimes we're going to keep the existing PRVs because they're feeding other application, and it works like a charm at 15 PSI or 10 PSI as well. Yeah. And there's extra features that we don't need when we, so we're a bit lower cost, low pressure steam than high pressure steam. Yeah, so I don't know if I answered everything on your question, but yeah.
Yes, and so so really it depends on the application, the situation, the kind of the working pressure, in the building. I think this is maybe doubling back on an earlier kind of discussion, Patrick, but what happens if the steam mains drip leg, the high pressure temperature condensate fails open, right, and passes live steam? Is there some risk there to?
So that's a good question, actually. Again, I discussed this in my video, but so we do provide, especially on a new project, a new building, of course, we will need drip legs, right? So we have a condensate mixer. You bring so we recommend to use bimetallic steam trap on drip legs instead of no bucket, no TD trap. I mean, come to our steam training and we'll explain why. I don't want to go over the mechanism of steam traps, but we use bimetallic on high pressure steam or thermostatic on low pressure steam on drip legs. That's what we recommend to bring the drip legs back to a condensate mixer. So I will not go too much in detail today. Subscribe to our steam training or give me an email or a shout, explain too much, but yeah, we have a condensate mixer, which is basically a sparger with inside two with multitude of orifices that we size based on the max loads and pressures. And you can bring multiple condensate return multiple drip legs. I mean, steam trap drip legs, multiple ones to one condensate mixer. And we use them also in tunnels and other application. There's more and more universities using those in their tunnels. Condensate mixer. But if we do a retrofit, the condensate return line for high pressure drip legs is probably existing. Or there's, like I said earlier, there's an existing flash tank maybe that we can use for those things. So let's go back to the condensate mixer. There's one downside, but I think it's a good side. So to answer the question about when there's a steam trap blowing, what's going to happen? What is it? It's going to bang in the condensate mixer. It's going to make bang, bang. You're going to hear water hammer because those bimetallic steam trap and thermostatic steam trap are fell open. So the good side is like, it's like a red flag. Hey, Mr. Customer, you have a steam trap blowing. It's time to fix it. That's the good side of it. The bad side is you need to do it now. Right? So it's a give and take. So it never happened that the customer went to a different route saying, oh, we're going to have a dedicated condensate return line just for drip legs. But to be honest with you, that's the way the condensate mixer works. So when the steam trap will blow, you will know that you have a steam trap blowing. Definitely.
All right. Thank you. Next question, next question. Has this technology been accepted? I think the question is the U.S. federal government, in particular the VA, the Veterans Administration, and if so, is there a way? I believe in the purchasing, requirements for those federal agencies, there may be like a 3 vendor minimum requirement. So, has Maxi-Therm been applied in federal government settings?
It's not our best market, if I should say. It's kind of complicated. We did project in the past with VA hospital. We did project with other federal agency, or I don't know what you call it in the US. In Canada, it's like minister,
Right.
So we did quite a few work. I mean, we had quite a few projects in Washington, D.C., if that rings you a bell. So,
sure. Yes.
It's a federal project. We are involved, but it's not always easy when it comes to VA hospital.
Yeah. Yes. Yeah. Understandably, the procurement process can be, challenging. But as far as like a technology or an application, there's that's not the issue. It's really just the nature of that beast, perhaps. But maybe that questioner could reach out to you directly, at the conclusion, and if there are locational references that you could provide, that might be of help to both of you. So next question, do you see any issue with your system sitting idle on an otherwise like central hot water system as a polishing peaking means? If, is there any risk to,
Any question, Rob? Sorry.
Yeah. Do you see any issue with your system sitting idle on an otherwise central hot water system? And it says as a polishing peaking means. So I'm not sure what the polishing peaking kind of notion is.
But interesting. We did project in the past that I remember one project in my mind. They decided to go like condensing boiler for the hot water loop, and they needed a steam boiler for the sterilization and humidification, but they select the steam boiler to do also building heat and use our Maxi-Therm as a backup when they running on oil. I don't know if you follow me. So when they're mainly using natural gas, they were doing hot water loop with the condensing natural gas. And we were the backup if they switched to oil. Instead of using oil in the condensing boiler, they were using the steam boiler. Follow me?
Yes. Yes.
Now, I will tell you why I remember that job. Because 1 year later, I think, no, 2 years later, I will not. So much pain with a condensing boiler, they switch everything on the Maxi-Therm.
Yeah.
No more condensing boiler.
Yeah.
So that's why I remember that story.
Yeah. Yeah. I mean, condensing boilers have their own sort of, unique sort of management operation.
To answer your question, we can be like on the side idling and waiting the call to kick on.
Okay. All right. So some level of dormancy is not a problem. Next question, we had some clients have concern that condensate blowdown, the pH, the chemical additives, and amount of water is wasteful. What would you say to them? I'm aware that in some like district energy systems, while the end user, the customer, may be sort of producing a fair amount of condensate. I'm also aware that in certain settings it's been aggregated. Sometimes it's used as preheat to domestic water, or perhaps another sort of on-site requirement. And I'm also aware like a location where the condensate from an area adjacent buildings was actually aggregated and used in a commercial laundry in one of the downtown buildings, right? So the use of condensate is not necessarily the responsibility of the district energy provider, but the solutions and optimization and sort of maybe effective use of condensate is certainly something that all of us that participate in STEAM want to have happen, right? Is that something that would get covered in the STEAM training that Maxi-Therm offers, sort of like how to utilize the inherent value of condensate, the water, the chemicals, the heat, etc.?
Yes.
It's loaded question. I'm sorry, I covered a lot of
to answer your question, we did projects. I remember, especially lately in New York and Detroit, also a couple of years ago. So let's say the application is building heat, and you want a hot water loop at 180 Fahrenheit. So and the return will be 160 Fahrenheit. Okay, at max load. So there's no way my condensate will come out at 100. It's impossible, right? So in order to have condensate at 100, you need low temperature set point and low temperature return, okay? So in the case of those two applications that I told you, because they were dumping to drain, they wanted to extract as more heat possible on the condensate, because the condensate were more around 150 to 200 Fahrenheit in those applications. So we did put a preheater for domestic hot water on it, and with the controls with like a quencher, but we didn't use a quencher. We used a three-way valve to make sure we're coming out at 140 before going to drain, because on domestic hot water you don't have a load on it 24 hours 7, but building heat, you do have a load on it during winter 24 hours 7. So we can basically, Rob, we do custom design based on custom.
Right. Sorry, I just got we continue to get questions. It's not unlike steam with a steam flow here is significant. If next question, if this and again, I'd suggest to anybody who has a question perhaps that wasn't fully explored, or you have other inquiry, please don't hesitate to reach out to Patrick directly after the conclusion or in the days to follow. Patrick, if the steam distribution is at 200 psi, is the heat exchanger rated to operate at 200 psi, or is the rating generally somewhat higher? Is there a safety margin in there for the heat exchanger?
Well, that's a really good question, and again, it's on my YouTube. But so the whole skid, not just the heat exchanger, the whole skid will be rated based on the last safety valve set point. So typically, the safety valve is on the steam boiler, and if the steam boiler safety valve set point is 300 psi, we're gonna rate the whole skid for 300 psi.
I see. Okay.
If it's rated for 600 psi, which we did in the past, we're gonna design the whole skid for 600 psi, even if we operate 100 psi. The reason why, it's not so much expensive to go 600 psi rating compared to 150, and we're gonna avoid any steam safety relief valve, vent to the roof, section 8, nothing. So that's the goal.
All right, very good. That's a good answer. What has been your experience with water hammer, right? So steam events where there's fluctuating water flows, specifically like sort of large fluctuations. I
know that in the past, like I remember my early years with my father, he was telling me a really bad story. I think it happened in New York, a big water hammer kills people. And the reason behind this that my dad explained to me at the time is what they were using as drip legs. It was a fell closed device, which is the flow trap, right? And when they're in tunnels like this in a city or in a big campus, those drip legs are kind of forgotten, and so basically my first advice is to use fell open trap, right? And you will hear them mainly, especially bimetallic. They have a big orifice, so you will hear it big time if it's blowing through. And and water hammer comes for what? It's whether fell trap, fell close. And maybe even if it's a fell open device, it might be plugged, so it needs to be checked. I mean, that's the maybe the pain of a steam system. But personally, when we do a new project, the steam trap we send has a drip leg part of our skid. Again, I don't want to, but we use German made. We want to make sure that they're going to last forever and very low maintenance. So again, I'm inviting people to use a good quality thing. And the other reason the water hammer will occur is a bad water treatment from the steam boiler, and you're making carryover all the time. And maybe bad piping design, not a big boiler header enough. So there's all kind of reason making generating water hammer. But to answer your question on our units, it never happened. Never.
All right, very good. Thank you. I know we've run a little beyond an hour. We're going to stay on for another few minutes, try to get to all the questions that have been uploaded. We're getting close to 50 questions so far. So Patrick, what is the inlet pressure to the flooded heat exchanger downstream of the control valve when full open? So if this application, they have 90 psig from their cogeneration plant out to the buildings, right? So that's sort of the operating distribution pressure. We have seen 50 psig inlet on other products. What control valve is used with the 50-to-1 turn down? Is it a V-port ball valve, or are there other options for that, for the higher turn downs?
It's well, the higher turn down, it's not because of the valve. We use a globe valve, but it's not because of the valve. It's because when we modulate, again, I refer to my video on YouTube, what you will see is we modulate also the surface area of the heat exchanger. I'm giving you the right surface area based on your loads. So it's not a question of what type of valve is it, a V port, a this and this and this. No, it's a question because we're playing with the heat surface or the heat exchanger. Again, I refer to my YouTube.
Okay. Yeah. So these are really kind of complementary design conditions. I think in your
and
your
also
right?
The beginning of your question, just to be sure, after the control valve, we are automatically at whatever is your back pressure. So as long as the steam pressure is higher than your condensate back pressure, no condensate pump is needed. So for example, like I said earlier, 20% of our project is low pressure steam, especially on the retrofit. So let's say we're coming at 10 PSI in the Maxi-Therm. And after the control valve, typically you want to lift because you don't want any pipe on the floor in your mechanical room. So let's say we're lifting 10 feet high, which will give you about 5 PSI back pressure. And then we're going back by gravity to the next flash tank. Okay, so if that case, if that's the scenario and the retrofit project lifting 10 feet high and then going in the flash tank, I'm coming at 10, 5 PSI back pressure, no pump.
All right, thank you. Another question, and these are actually related. When is hot water a better option than steam? As I think you mentioned, sort of the move towards like lower temperature hot water systems, or
I think it's the emergency level of taking care of, especially on, I know there's a good article coming in your next magazine about Seattle, and what struck me is 130 years old. So is it pissing here and there? I mean, leaks here and there, it is. You don't want hot water leaks in your big network. I mean, don't get me wrong, if it's a small school, a small building, I will go hot water. I'm not saying steam and probably gas or electric boiler. I mean, but on the district energy, and what I like about steam, that's the first advantage of a steam district energy loop, or even a hot water loop, to be honest with you. I mean, district energy, the biggest advantage is we have one stack to take care of, one boiler room to optimize, and maybe have a future fuel, burning trash, burning biogas, burning grass, fat from the restaurants and everything, like vicinity does, and getting more greener and greener and greener. And a user of steam, they don't have to do nothing.
Right. So the aggregation, the advantages of scale really do kind of work here. The economies of scale.
I mean, you let your provider getting greener, and you use steam the best way you can. So our footprint is very small. The maintenance level is very low. So just advantage.
Basically, make it so let me, in the interest of time. So. A related question, there's a big trend towards like heat pumps and lower temperature, hydronic systems. Do you see a value of maybe a hybrid application where there's a combination of hot water and steam, but you use, using heat pumps from time to time? I guess you're probably going to say it depends on the location, and these are all sort of, custom solutions. But how do you see this sort of conversion or, transition happening, if at all?
We are more and more involved combining heat pumps. Like I said, the big trend in the market now is going low temperature control on the hot water side, because there's heat recovery from the existing chillers, heat recovery from not heat recovery, but we want to implement geothermal, we want to implement solar. So all those works, but they cannot supply the full load all year round, right? So you need like a gas boiler, electric boiler, and quite honestly, what we are a steam fired boiler. That's what we are. So we are involved in some of those more and more. To be honest, when Maxi-Therm started, the pace of design was a 180 Fahrenheit set point, 160 Fahrenheit return. Now we have more and more projects, even 100 Fahrenheit set point with 80 Fahrenheit return. I mean, we never saw that when we first started. But now we see more and more projects with low temperature set points. So I think I answered your question, just to be sure about getting involved with heat pumps project. Obviously, yes.
Yeah, you can be integrated, and actually the next question: do you see networks where there's maybe a central steam loop, and then the adjacent properties are served with a hydronic, kind of like a maybe where
Yes.
I mean,
more and more big projects. I mean, I was discussing with my cousin lately, and it's crazy how much we quote more and more huge project. I mean, when we first started, everything was between, I will say, 5 to 15 million BTU load. Now we're having requests between 30 and 60 million BTU loads, like big units. And that's, I think, it's a trend. It's like using steam as a first main loop, and then we do hot water for maybe 3, 4, 5 small building around.
Yes.
You know what I mean? So that's a trend that I see a lot. Yeah.
Yes. In cities, do you see building codes requiring a pressure relief valve on a 150-pound steam supply service? I mean, is there a requirement that there be sort of 2-stage PRV when the steam network, the district energy system is providing?
I mean, a lot of district energy, the safety valve on the water, it might be, I don't know, 400 PSI, 300 PSI, but they have another safety valve on the loop somewhere at 175 PSI, right? So in this case, we'll be rated at 200 PSI because it's always based on the last safety valve set point.
But do you see building codes requiring like PRV? If the working pressure is that you haven't.
It's always based on the last safety valves. Quite honestly, I don't remember any building.
Okay. There's a question here that's more housekeeping about PDH. We're not offering PDH. Continuing education units for the seminar. It's turned out it's basically getting it. So the answer is no for the time being, but no for this one, just to answer that question. Back to Maxi-Therm and your equipment. Patrick, are the heat exchangers vertical U-tube? Are they shell and tube design with steam in the shell, or are they plate and frame?
Correct. It's a shell and tube.
Shell and tube. Yeah.
Steam in the shell and condensate in the shell, and water in the tube. Yeah. Made in Connecticut. Copper nickel tubes come from Brampton, Ontario, and carbon steel come from Pennsylvania.
Very good. This next question is, what type of meter is best used to monitor consumption of steam in a district heating system? Maybe somewhat outside the the context here. So I don't know if in your experience you've seen sort of meters that are more effective than others. I know it used to be like orifice plates, and in the old days, Cadillac flow.
We do have a flow sensor on our system. So the flow sensor we use is again, video. I'm sure I'm going to have a lot of views.
It's going to be viral. Yeah.
Likes also, but the thing is, the flow sensor we use is not super accurate. Okay, the benefit of using this is it's part of our startup sequence. So again, go see my YouTube videos. It's like no flow, no steam, right? We always need to read flow. And number two, it gives you a good idea for troubleshooting, knowing are you at low load, high load, mid load, just to give you, and you can refer to the valve opening rate also on the condensate. So it's really good for troubleshooting. Now, if the customer wants something more accurate, we can certainly check for another another flow meter on the water side with low temperature condensate, and not on the steam side, which is expensive, and not only expensive, but maintenance, So that's the big advantage of our unit is since we're delivering let's say cold condensate, is not cold, but you know what I mean? It's like there's a lot of flow sensor rated for 250 Fahrenheit, so we can use those.
Very good. And if the person who asked the question is a member of IDEA, you could also post that question on our IDEA Connect and share that out with the full community, and people may be able to help you with metering technologies or tools that they've used in addition to Patrick's insight. So next question, Patrick, this says we are a central steam plant presently investigating our options for the future, and of course seeking to reduce their carbon footprint, right, their carbon emissions. Has Maxi-Therm performed high-level studies for facilities? Is there in terms of, the services you provide, is that something that,
not really.
Yeah.
I wish,
Yeah.
but we are. By the way, we have a great group of people, not only inside Maxi-Therm, but our local representative.
Right.
We really high knowledgeable people around us, and we are involved in some of those engineering firms and energy saving company, and to help them to figure out what's the best solution and the best way to improve this team network. So if you want us to be involved with your favorite, let's say, consultant engineer firm that you like to work with, we'll be more than pleased to work with those guys and help them out to figure out.
That's helpful. That's fair. And I think to the questioner, again, not at the risk of being sort of self-serving here, the IDA Campus Energy Conference is coming up end of February. Grapevine, there it is on the screen. Decarbonization is a very strong component of the there's nearly I think nearly 200 presentations to be planned at this conference. So I think if you can see your way to attend the IDA Campus Energy Conference, I think you find a lot of information related to master planning and decarbonization. That really is the focus for a lot of our member systems.
One thing I'd like to add, it just popped in my mind, since we'll be at Chicago in June at the IDEA, if some of you guys would like to go, some of our unit in operation, we have quite a few in Chicago area, send me an email and we can arrange that during that week.
Very good.
Please, yeah.
Very good. Next question, is there a patent on the flooded design system by Maxi-Therm? And if so, or if yes, how, again, this goes, how can state and federal buildings specify these systems? Might be some,
that's a good question. It's kind of tricky. So we do have like 6 patents now on different solutions. One of the latest, is the one I showed you for the boiler room. We're working on a 7th one right now. We're waiting to have some feedback on our agent. So to answer your question, the best way to go with some consultant engineers we've done in the past is I'm not sure I should say this. It's
sole source.
Yeah. Is to design everything over Maxi-Therm. Okay, and then the spec comes out typically, and it says Maxi-Therm or alternative
or equivalent.
Yeah, but they need to redesign everything because you know what I mean. So if you want to go conventional way, you need to fit the footprint and things of that nature. But it's there. The option is there.
Yeah.
You need to submit the equivalent during the quotation process, if I should say. So there's some trick here and there. It's not always easy. It depends also on the end user. Some end user on federal building wants to use Maxi-Therm. And one of the reasons they want to use Maxi-Therm is, I think, is the word of mouth. We are well known to respond quickly. There's always issues. Don't get me wrong, there's always issues, right? So we respond very quick. We're not afraid to take the plane to go in. There's always something to do else around. We respond, So that's one of the reasons people like to do business with a family-owned business. We're kind of quick on responding on everything,
and I mean, at the risk of being, unreasonable or too duplicitous or even unfair, I think one thing that's sort of apparent now is that steam has been widely applied and used in federal buildings, and so I think there's a lot of it's a sizable market looking for good technology and solutions. So for what it's worth, I'm no expert, but it seems like there that there maybe is more demand here than but I'll leave that to the good folks at Maxi-Therm to kind of explore that. I know we're running a little long. I'm getting a little fuzzy, but do you still have an issue with safety inspection bringing high pressure steam into a building, say, versus an outside PRV system? You know, is the working pressure, you know, is that any difficulty there?
It's never been an issue.
Okay.
The only time I remember we had an issue, and that's many, many years ago, and it was a mistake from, I don't like to blame anyone, but it was a mistake from whether the end user or the consultant engineer. So here's what happened. There were 3 safety valves on the steam boiler, okay? They request our system to be rated at 150 PSI. Okay, so when the inspector came, he went on top of the boiler, and there were 3 safety valves. 2 of them, I think the set point was 140 Fahrenheit, but there was one safety valve was 160.
Oh.
So because of that, our system was refused.
I see. Yeah.
Make sure your safety valve set point. That's my point.
I see.
Otherwise,
Right.
we never had issues. Never.
Okay. All right. Very good. This question I think relates to one of my thoughts. If non-metallic piping is going to be used on condensate, if not carbon steel Schedule 80, have you had customers use, you know, PEX or plastic pipe, and what type, and on what type, and what type on condensate, like flexible tube, or what have you seen?
Directly involved. Those
Yeah.
guys, sorry, I got a blind. I hope he's not on the call, because I know he's participating at Campus Energy and IDA every year.
Yes.
They are located in Alberta, in Toronto also, if I remember correctly, and I have a blank in my mind of their names. So I know they're going to be at your show. So come at my booth, and I will introduce you to those guys. But I know that they are involved more and more in different campus, and also District Energy. And they've been asking me a lot of questions, because the question was, I think their piping is rated for 250 Fahrenheit, if I remember correctly. So the concern was about drip legs, right?
And exposure to, right.
That flash steam, I mean, drip legs, what's coming out of flash steam is little water drops. So if it's mixed on our condensate mixer, it won't reach 250 Fahrenheit, especially if the condensate is 120. You know, so it's really a case by case. So when you're planning a new project, I know vicinity, and I don't know if it's Boston or Cambridge, they have a new building. They're going to feed them steam not too far away of their power plant, and they will go that route. They go Maxi-Therm and that route with non-metallic condensate piping back to the boiler room. So it's a new trend, and I think it's wonderful, because to be honest with you, Rob, the pain in the you-know-what on the steam condensate loop,
yes,
is the condensate pipe. It's not the steam pipe. There's no corrosion on the steam pipe. It's all condensate pipe, right?
Yeah, and condensate at low temperature, they're exposed to snow melt and salt and corrosion.
And from vents from flash tank everywhere. That creates a lot of corrosion. That's the reason.
Right.
System, there's no more air injection, because the vacuum breaker only opens when you shut down the system. Otherwise, it remains closed. So there's no air injection from the heat exchanger, no flash tank anywhere. Plus, you're adding a non-metallic condensate pipe. That, I think, answer everything about steam.
So, I know we've run a little bit longer than anticipated. One last question, or last bit of questions. What are your thoughts on replacing steam with geothermal heat pumps for carbon mitigation? That, you know, that is a kind of a trend we are seeing in some of the campuses. Any thoughts there?
No, not really. I think maybe I'm wrong. I'm not too familiar with heat pumps. What I hear is it's like a bit like condensing water. It's kind of a high maintenance piece of equipment. But maybe I'm wrong. I just want to say that's all I know. I'm not familiar with heat pumps to answer that question.
Yeah, very good. That's fair. And then let's see, is there a question here? Let's see. Okay. So what do you say to universities wanting to de-steam their campus? So, you know, let me just kind of offer this. You know, I think steam is not the problem. It actually can be, you know, the solution in a lot of ways, right? But you know, would it be safe to say to universities, hey, before you take the path of decommissioning steam, maybe look at using steam more effectively, more efficiently, and kind of considering Maxi-Therm in lieu of something else. I probably said more than I should, but
so let's say they decide for whatever reason to go hot water, high temp, high pressure, like we saw 250 psi. The first thing I will say is when it will get cold, like old steam system we have all over the country, and starts to leak, you will miss steam because you'll need to fix it right away. And when you shut down a hot water loop, it doesn't take an hour. It takes forever to cool down. And then you need to purge all the line before, it's not like an easy work to work on a leak on a high temp compared to steam. That's the thing. So getting older and older, you'll have more and more leaks, just like a steam system, right? Then what's the next step? So the next step, typically, if we go decarbonize, is to replace the source fuel.
Right.
So at the end of the day, you keep steam, you replace the over time, the fuel with green fuel, whatever you're gonna pick, whether it's electric, nuclear, or trash, biomass, biogas, name it. I think steam, you can generate power with it. I mean, there's steam certainly there's so much benefit in my eyes. Just the maintenance guys are gone. So you want something you need to fix right away, or you want something that you can plan that fixing and take your time, if I should say, So,
well, one of the participants has made the comment that I think the move towards lower temperature systems is also to be able to sort of utilize lower temperature sources, or what was otherwise sort of waste heat to the environment, right? So data center heat, or sort of other sources. So it's more like the gathering and utilization of a range of systems, or what were otherwise sort of wasted, heat resources. So, but I think. I'll let you kind of conclude with a thought. I think you've made a very solid argument that steam has a number of advantages, but at the same time, it really does need to be like a locationally, kind of sort of it's the case and the conditions in that location. There's no one size fits all here, right? I mean, and I think I'm looping around on myself now, but
my big thinking is if steam is nearby, I would consider steam if I was a building owner. If steam is nearby as a district energy, and then because you don't need to ask yourself if I need to change fuel someday, you let the district energy guys to do it. That's right. Number one. And number two, if you need steam for process, well, if I'm buying steam water, I will buy steam water to do the whole 9 yards, domestic water and everything else. And one downside of steam that people came to me a lot is, I need a stationary engineer. 24 hours, 7, depending on the size of the steam water. Well, in my point of view, if you're a big hospital, a big factory, or a big building, those guys are an asset in your maintenance crew. So it's not like a waste of knowledge there. It's if you want to keep your building properly running for any kind of situation, chillers, pumps, and everything, those guys are valuable. It's not the janitor.
Fair enough. Fair enough. Patrick, could I ask you to advance one slide so I can bring this, I can wrap? Thank you. Well, I want to thank you so much for making yourself available, really, for sharing all your experience, your expertise. And as Patrick mentioned, Maxi-Therm will be present at our upcoming IDA Campus Energy Conference. The link to that conference is here. For those of you who still have unanswered questions, or perhaps beyond, the issues sort of surrounding the use of steam. I think you'll find there'll be, nearly 1,000 people at this conference, and I'm certain that you'll find answers to your questions and many more. So please make a plan to join us. IDEA will continue our I&I webinar series next week, February 1st. The presentation will be by Phaedra, and their discussion will be on preparing your district energy system for application of artificial intelligence. How do you, what data do you organize, and how do you move your system forward into the future? And then finally, as Patrick mentioned, we'll be convening our 114th annual conference in downtown Chicago, June 5 through 8, IDA 2023. We had an overwhelming inflow of abstracts, almost a 2.5 to 1. The presentations are actually being curated at the moment. And the theme of that conference is empowering the next generation, which is congruent with Chair Dave Musto's notion that we need to engage sort of the next generation, not only of assets, but of people. So registration will be opening soon for that. I think Patrick, I think we had 54 questions. I think you stick handled all of them with great skill. And I'd urge anyone who's on the call, if you have additional inquiry or want to understand more how to utilize the resources of Maxi-Therm, please reach out to Patrick. Again, IDEA will be compressing this video, and it'll be made available in streaming to all who are registered. And then I'd urge you to just continue to connect with us at IDEA. And Patrick, again, let me conclude by saying thank you for really giving us, I think, a valuable lesson on steam, its advantages, and how Maxi-Therm can help our community, solve problems, save money, and really do good work. So thanks. Well done.
Thank you very much, Rob. Thank you.
All right.
Thank you for that opportunity. Thank you very much.
Our pleasure. So with that,
we'll see you in Grapevine.
Yes, very good. All right, safe travels, and look forward to seeing you all there. Thank you. And that brings us to a close.